flux through a cube. Consider a cube of sides A. So the sides of the A is given. So it's cube. Suppose that electric field is present and given by, so the electric field is given by an equation where B x power of n, and this is a direction of the x vector, where B is given and n is given. Calculate the magnitude of the total charge within the cube. So we have to find a total charge within the cube. Okay. So say that we have a charge, okay, inside of it. Then we know that a flux is equal to the EA equal Q divided by the epsilon naught. Now, before moving on, we have to know the certain rule. When we have x vector dot x vector gives you 1, and x dot y gives you 0, x dot z gives you 0, okay? So that means we have to consider only x vector direction in this case. So our x vector direction, we will take this shaded area. Okay, let's want to take shaded area. In that case, what do we have? We have area vector, right? That means in this case, area vector will be equal to the a squared and direction of the direction of the x. Okay, this is just direction. That means the flux is equal to the EA, which is equal Q over epsilon naught. From here, we can say that our Q will be equal to the epsilon naught E times area, right? So that means, let's say this side will be a flux 1, okay? So the flux 1 is equal to the electric, so epsilon naught. Electric field is equal to the B. Now, since x in this case is equal to what? X is equal to the A. This is the length of A, right? When x is equal to A, what we will get? We get E is equal to the B. Now, instead of x, we plot A times power of n, x vector multiplied the area. Area is equal to what? Area is equal to the A squared x vector. Now, x vector times x vector gives you 1. So what we have epsilon naught B A n plus 2, okay? N plus 2, because this multiplying those things. Okay, so what we got? So we got this one. Okay, so let me think. Yeah, this is basically, if you take this one as 1, this has to be charged, okay? Charge. So the charge will be, finally, the charge will be equal to the epsilon naught B A n plus 2, okay? Now, what about other side of the cube? This side. In this case, what we have, we know that our x is equal to 0, correct? Because if you take this one as a 0, then obviously the flux is equal EA. Now, if you put the 0 into this x, what you will get? You will get basically everything 0, right? So that means we only end up with this formula where Q is equal epsilon naught B a power of n plus 2. So you plug the numbers, b is given, n is given, epsilon is given, so you can find a charge.